I'm very pleased to have a special guest on tonight, and we will get to him in a minute. I want to thank Barney Scholl, the Vice President and Co-Counsel of the Radio Club of America, for coming on tonight to watch the Q&A and the chat. If you have questions for Nick, please put them in the chat or the Q&A, and Barney, we will take various stops along the way, and Barney will take care of that. I do want to introduce our special guest. It's Nick Tusa, and Nick is a long-time amateur radio operator, but more importantly, too, he's got a lot of experience in communication systems. Good evening, Nick, and thanks very much for being on.
Hi, Tim. Barney, it's good to see you all.
So, Nick, why don't you tell us a little bit about how this all started? I mean, how did you get interested in radio, and then what did that lead to in your field of study, and then starting a very successful consulting business?
Wow, great. I feel like I've always been interested in radio. I was a young kid. I remember taking my grandmother's radio apart in a kitchen when I was probably about 6 or 7 years old, because I wanted to find out where that music was coming from inside that box. And the fellow across the street was into having a home business rebuilding television sets, fixing them. And I would go over there and kind of watch what he was doing, and it really piqued my interest. I got my ham license, my novice license, when I was 11, and quickly just went through the ranks of becoming a general and advanced class back then. And ham radio has just been such an important part of my growing up years. You know, we had a ham club at my high school. It was quite active. In fact, a lot of the kids that I went to school with who were hams, we're still friends today. We get together quite a bit. So it's one of those things that I always wanted to do, because I wanted to build things. I knew that even in high school that I wanted to be an engineer. I felt like that was the direction I needed to be in, because I like to take things apart, and I like to question how and why things work. And I believe that's an essential quality for engineers, to question how things work, how to make them better, how to improve upon the past. And that's why I'm interested also in the history of radio. But it kind of dovetails into my work. I started my first business. Well, first I was hired by Exxon Company USA in 1978, 79 to be an associate engineer. We were doing radio systems out in the Gulf of Mexico along the coast for production platforms and exploratory drilling. Most people don't realize back then the phone company stopped where the land stopped. And if you needed to have telephone service on these production platforms or data services, the oil companies had to provide that infrastructure. And that's what I was hired to do, to help build radio sites offshore along the coastline, build microwave networks, that sort of thing. And that led me to become a contract engineer. I was doing the work for other oil companies after I left Exxon. And finally, in 1985, I started my first business, which was Crescent Radio Electronics. There we designed one-off products that the oil industry needed. They had lots of needs for electronic devices, but very low production. So we would design them, prototype them, and build them and service it. But then I got involved in radio paging. Paging was making a transition from analog to digital paging. A local paging company called me up just about maybe 2 months after I'd started business. And he said, look, I'm a private carrier pager. I'm trying to go after the business of these radio common carriers, but they're operating digital and I'm just analog. What can you do about it? I said, well, I don't know, but I'll figure it out. Turned out it was like radio teletype, and I was heavy into RTTY as a ham. So we experimented with how to build modulators for these analog transmitters to convert them to digital. And that turned into a product line that we sold, well, for several years until cellular effectively pushed paging out of the way. Then in 1992, I started my consulting business, just me as a solo radio engineer. Started working for local public safety agencies. And then eventually in 2005, I opened my business up to partners. I brought several other people in. We expanded the operation. And today it's a nationwide firm. We do consulting for cities and counties throughout the United States. We've done some work for several states now. It's something I really enjoy doing.
So how many people are with your firm now?
Well, that's the good thing. It's not my firm anymore. I sold it in October of last year to its chief operating officer, Dean Hart. And the reason I did that was I felt it was at a point where Dean had done so many good things for the company, and I was looking to try to do some other stuff outside of just public safety consulting. So I still do work, contract work for the company I founded, but I'm no longer running it. And I'm enjoying that because the personnel stuff and chasing down invoices and other things were becoming more and more of a departure from what I love, which was just pure engineering.
So Nick, why don't you talk a little bit about some of the big projects that you did or are involved in right now?
Well, the first projects that public safety projects was at the city of New Orleans. I became a contract engineer for them at first, building out regular repeater systems because they weren't into trunking back then. This was in started doing that in 1988. And then the city wanted to move into a trunked environment. And we designed and built one of the first trunk radio systems down here, the simulcast network for the city of New Orleans. That was in, we started it in 1991 and completed it in 1993, almost 94. That was a system that most people know about from Hurricane Katrina. But that one project led into several other simulcast networks that I built throughout the Gulf Coast, into state of Georgia, down in South Florida. The biggest system that I was principal involved with was Kansas City, Missouri, where we built a new P25 trunk radio system for them. Actually fixed a earlier analog trunk system that was having coverage problems. Then morphed into a P25, Project 25 digital radio network that became a regional network, encompasses multiple counties, close to 40,000 radio users today, approximately 46 tower sites, loop microwave networks to interconnect all the PSAPs, public safety answering points. It's really turned into a fabulous radio, regional radio network. I'm really proud of that work.
Yeah, well, that sounds like a huge project, you know, and managing all of the intricate details. And I want to get more into that. And we really want to encourage all our participants to and viewers to ask questions in the Q&A or in the chat, and we will cut away for questions here in a minute. I do want to remind everybody that whether you're a member or not of RCA, and if you're not a member, consider signing up. Just go to radioclubofamerica.org for more information on how to become a member of the RCA. And we have two important announcements. One is we do have more of the books available. Cutting the Cord that Marty gave during the our banquet speech, Marty Cooper, and Cutting the Cord. We do have books available through the website, So just go to radioclubofamerica.org, and you can see all the details on how to obtain one of the, and it can even be personalized by Marty Cooper, who was one of the inventors of the handheld cell phone. Basically just changed our life forever. We also are taking bids on the 2 CW keys that were used last Saturday night by our president, John Fasella, as he reenacted the transatlantic test at 9:52 Eastern time on 160 meters. And there are 2 CW keys, and we are taking bids on those as a fundraiser for the Radio Club. And you can find out more details at radioclubofamerica.org. And Barney, why don't we start with some questions for Nick? I see a couple in there, and let's see if we can get this going and get some interaction here.
Make sure I turn my audio on. There's a question from K9SUL. Question, Nick, is there any plan to make the CE coupler design and construction know-how available to hams? With low-cost VNAs and other test equipment, hams today will have a better chance of replicating CE couplers.
Okay. Yeah, I get asked that question quite a bit. When Wes Shum, who was the founder of Central Electronics, he and Joe Batchelor, I wanted to make those broadband couplers too. What this device does is a high impedance to low impedance transformer for RF transformer for radio transmission. And the neat thing about them is it has a band pass that you can design for each amateur radio band, where you don't have to, with a tube transmitter, tune anything. You don't have to adjust the plate and load condensers to resonate the output network. It does it automatically without motors. It's a passive network. They invented it and perfected it and used it in their transmitters that were built first by them, the Central Electronics 600L amplifier and the 100V transmitter prototype. I got Zenith Radio to actually take the company over and produce these things. But then suddenly it disappeared, and Zenith had deactivated Central Electronics for tax reasons. So the information about the couplers has disappeared, and I wanted to try to build them myself. I started trying when I was in my senior year at Tulane University in electrical engineering, and that's how I started conversing with Wes Shum. He wouldn't tell me how to do it. I had to do it by trial and error. And eventually I got him to work. And I brought him up to Chicago, and we had a great time about that. But he made me swear on a stack of QSTs I wouldn't tell anybody else how to do it as long as he was alive. So he's since a silent key. And when I wrote my book, Wes Shum, Amateur Radio's Unsung Hero, which has just been published, there's information in it about the broadband coupler and how they're made and how someone can get started. But just like Wes did to me, I'm not going to tell you exactly how to do it. I expect you to get out there in your workshop and try it yourself. And you can call me and send me messages and I'll coach you along, but there's sweat equity along the way.
So tell us a little bit more about the book, Nick. I haven't picked it up yet, but it sounds like it should be a fascinating read.
Well, it's a story about a man that had just a remarkable life. He was right in the thick of things during World War II, working for a company that built lots of different products for the war effort. And he had been involved in communications when he was in the military, and picked up ideas about how he could bring single sideband to the amateur radio field. Sideband was not invented in World War II, but it was certainly perfected and utilized during the war. And he saw where it had great benefit in terms of eliminating the tremendous amount of heterodyne interference caused by AM stations, amplitude modulated stations in the ham bands. So he helped promote the idea of single sideband, developed a low-cost system initially for amateurs to experiment with single sideband and actually use it, a way in which to transmit it and also receive it. And that's what got his company started in 1951. But then he promoted it all over the United States, providing seminars to explain how single sideband worked, how it had so many advantages over AM, and really bootstrapped sideband into mainstream use. It got the attention of other companies. In fact, he even sold his little 10A exciters, which were rudimentary single sideband generators, to Collins Radio when they were experimenting with, just starting to experiment with single sideband. I became friends with him. He was my mentor. He was the best college professor I ever had, and I had him for close to 45 years, and he was just fabulous. And along the way, I learned very much about his life and his life story and the products that he developed, things that people don't really think of in terms of the amateur business. For example, right after the war, he learned through his new wife of a school in Chicago that was trying to teach profoundly deaf children to hear and to speak. And he developed a set of equipment that helped them to hear for the first time, which is quite remarkable. It's in the book. And then just the way in which he approached life. There were lots of obstacles in building a company from scratch. It started in a basement, then in a garage, and eventually got sucked up by Zenith Radio and then turned off suddenly. So the point was, I was hoping that it might inspire young people if they read it. I was thinking that hams would get this just to learn about the history of single sideband, but maybe they would see in it a story that they could talk to young children, their children about, or grandchildren, to get them interested in a career in electronics, and also learn that you learn through doing. And failure is not really failure. It's just an opportunity for you to learn more, to dig in deeper, to determine why something that you expected, a result you expected, didn't precipitate. And how do you fix that? Or how do you resolve that? So I felt that his story would have been important for children, young people, people just entering in engineering, or people that's thinking about starting a business, to know that there are going to be obstacles along the way. But if you really want it and you want to succeed, you'll find a way to do it. And he did.
What a great story, and a super mentor for you and others as well. And do you have any of the equipment that Wes's company built in your vast collection there, Nick?
Oh, sure. Yeah. I used to go up to Chicago and help him build his high voltage test set line. I would fly up there or drive up in the early part of the week, and we would work together down in his basement factory. I used to call him the subterranean ham, because he had all of his factory equipment underneath his house. It was really incredible. He built everything: enclosures, circuit boards, etched his own, put it together, wiring harnesses, the whole smash. So you had raw materials that came in and finished product that came out. It was great. And nobody knew it was there. That was the funny thing. It was in a pretty affluent area too. So somehow he kept it under the radar. But you know, I'd help him do that, and he would help me in terms of teaching me how I could buy components at a rate and at a cost where it'd be economical for me to actually build things and make them profitable. You can't just buy parts in small quantities from Newark or Allied or any of those other suppliers and have enough margin in it to make a profit. He showed me how to do it the Wes Shum way, which was quite eye-opening, and it served me well. But I couldn't have had a better teacher, I can tell you that.
Yeah, no, and I really do want to get a hold of your book, and maybe you can tell us how we can get your book.
Oh, it's easy. All you have to do is go to Amazon or Barnes and Noble. If you go to Amazon, you just put in the search bar Wes Shum, and it'll bring you right to it. As far as products, I've got his Central Electronics radios here. In fact, I've got many of the prototypes. I have the 100V prototype. I have several 100 and 200V transmitters. I've homebrewed my own high power amplifiers using the broadband coupler scheme that Central Electronics pioneered. It's just been a very great way for me to learn a lot about the theory behind radio communications that you just don't get by reading a book. You just have to do it.
Yep. No, and what a treat, 45 years, Nick, that you had with him. Barney, some additional questions.
Relative to Wes, Nick, when did you first meet Wes in person?
Well, I wrote to him when I was in high school and college. I met him for the first time in 1982. I had got my broadband coupler prototype to work, and coincidentally, I had enrolled in a microwave class up at Motorola in Schaumburg, Illinois. So I toted my prototype up, went to the class. After that, I met Wes for the first time. And the funny thing is, you know, you talk to someone on the telephone for years, you write letters to them. In your mind's eye, you have an idea of what they look like and how they act. And he was exactly that same person when I met him in person. It was incredible.
And what was Wes's call?
W9DYV, Delta Yankee Victor.
Delta Yankee Victor. So he probably received his license pretty early on.
In the mid 30s, yeah. In fact, it's funny part, it's a little bit of the story in the book. It talks about how he and a couple of friends homebrewed equipment to work on what would have been between 6 and 2 meters and communicated across town, of course, without a license. It wasn't until after he read the handbook closely, he realized he needed one. So.
Well, I know Bob Heil speaks very well of Wes Shum.
Yes.
And they were good friends as well. And so, but I'm thrilled to learn about your book. And so these days, you know, what is life like for Nick? I mean, are you doing, how much consulting work are you doing? How much ham radio work? And tell us about some of your other hobbies.
Oh, well, you know, I'm still involved in public safety communications. In fact, we just completed a RFP and proposal evaluations for one of my clients up in North Carolina. I've been working with them for close to 10 years. They had a VHF Project 25 trunk radio system. Now we're moving them to 800 megahertz. Because they needed more capacity and also to resolve interference problems on VHF. There's a lot of issues with co-channel interference from, they were licensed systems, but they were some distance away. And it, of course, with sporadic E, occasionally they would cause interference and disrupt their communications. So we're trying to move them up to 800 megahertz now. And also, believe it or not, they want to build out a paging system, which was right up my alley. So we're doing that with them too.
Well, you know, if you hang around long enough, stuff comes back in style. And so it's interesting to hear that paging is coming back.
Yeah, I found that out myself too. Yes, if you hang around long enough, it's amazing what'll come back.
So
kind of like old ties, you know.
That's right. Yeah, just don't throw them away ever.
No.
Tell us about some of the equipment that is around you there, Nick.
Oh, well, this is all Collins S-line stuff here. I also have the older A-line equipment downstairs. John has seen my shack. He knows what it's like. But downstairs, I have the heavier stuff that if I brought up here, upstairs would be downstairs in very short order. I've got two TMC GPT 750s, which are 875-pound behemoths that I've restored. Or I've restored one. I'm in the process of restoring the second one. And also have a Johnson Desk kilowatt down there. And just bunches of receivers, lots of military stuff. I'm kind of getting a little bit more interested in the TMC line of equipment. I think I've gone about as far as I can go with the Collins stuff. I've got a URC 32, which is Collins is, I believe it's their first synthesized radio, transceiver that they made. It was for the Navy. It's in an upright rack, runs about 500 watts, but it uses a combination of some miniature vacuum tubes and solid state in all the different modules and assemblies and units. So getting it running was certainly a challenge. And that's what's fun about doing this vintage stuff. It really pushes you to dig back into theory, understand how these engineers did stuff back. And it's amazing the type of performance they got using so few components. It's just incredible. Today, we got radios that have integrated circuits with gajillions of transistors jammed into them, and they did all this stuff with, you'd be lucky to see a radio that had more than 20 tubes, so it's quite remarkable, really.
Did you ever get out to Cedar Rapids to Collins?
No, okay. I never did. No, I was always at Shum Electronics.
Underground.
Underground. You guys wanted to talk about hardening radio systems, I thought, tonight. It looks like it's going to be ham radio hour.
No. Let's talk about hardening systems, Nick.
Well, I learned the techniques really through self-preservation when I was working at Exxon Company USA. I started out there and had to immediately go to these offshore oil platforms. And back in the day, you did this by boat, either a supply boat or what they called a speedboat. Now, a speedboat to the oil patch world is a boat that does about 12 knots. Now, a crew boat does a supply boat does about 8. So it's not a whole big difference between the two. But what happens is you get beat to death, because by the time you actually get out to a production platform, you may be on a boat for 8 hours in 8-foot seas and just getting pounded the whole time. So after you've done this a few times, you start thinking of ways to limit your exposure and how often you have to go out. And you certainly don't want to have to go back out to repair anything. So that's why I started thinking about, well, how can I make this stuff so it doesn't impact me as much? It continues to work in the worst of circumstances. The other thing is that Exxon, at that point in time, there were no personal computers. So we had mainframes in downtown New Orleans that operated these platforms remotely, as long as we had secure microwave communications. And that was the key, is how to make the microwave communication links stay up when they evacuated personnel. And they still operated the platforms and were still producing oil, because Exxon wanted to make money. And you make money by having oil coming out of the ground. In fact, first time I was out there on a production platform, there's this god-awful noise. It's screaming noise. It sounded like a jet engine right next to your ear, right? And full throttle. And I asked the tool pusher, what is that noise? He said, son, that's the sound of $1,000 bills being shoved through a pipe at 20,000 pounds per square inch. That's how I got the message, that, you needed to build these systems so they never broke. So we started using battery backup systems. We'd have microwave systems that would operate on batteries for 72 hours, if not longer, because that's how long people would be gone from the production platforms. You had to build stuff so it would survive in the Gulf during a hurricane. In a hurricane, you might have 120 mile an hour winds by the time it hits, after it hits land and comes inland. out there in the Gulf, it could be 150 with 40 to 50-foot seas. So everything had to be built super rugged to withstand the vibration and the shock. Antennas had to be built very rugged. And those are the techniques I brought to my public safety jobs because I didn't want any of them failing. Katrina is a good example of what happens when you have a wide area catastrophe that affects a city to the extent that there's no electricity, there's no gas, there's no sewage, there's no water, there's no nothing. And everybody's on the water between 12 and 20 feet, covering 80% of the land area of the city. You don't have any police because the police cars are underwater. You don't have any fire because the fire engines are underwater. You don't have any EMS either. And besides, even if they'd survived, you couldn't drive down the streets because they were all flooded. Got nothing but boats running up and down Canal Street. If anybody's been to New Orleans, they know what that is. So, you have to build these systems to really survive. And you know that they're going to be damaged in some respects. You have to think ahead about failure modes and how the systems can fold down, but still maintain some degree of communication capability. And I think that's the art in building these systems hard.
So, Nick, when you're talking about communications to some of these oil platforms and in hardening these systems, and you're going through a time period where we had analog microwave and then digital microwave, and a lot of emphasis on diversity. I mean, you're going over water, which can really be a problem in the gigahertz area, right?
Right. Well, it's a big problem at 6. We used a lot of 2 gigahertz, which didn't have as severe a fading issue. But on the 6 gigahertz pass, especially on water, because it's flat, it's as far as microwaves concerned, because it's such a large area, even though it has waves, it looks like it's a flat mirror surface. So you would have reflection issues. The way around it, we'd have to use space diversity, which is difficult to achieve on a production platform because the vertical space on the platform is kind of limited. We'd have to put towers out on these things, and they would have to be built to survive the same harsh environment that the platform did. So you wouldn't see any of these towers on shore, let me tell you. But yeah, we used a lot of space diversity. We try to keep the path segments relatively short. We had some that were maybe 18 miles, but on those long paths, we'd have space diversity, but also have loop protection too. Now, back then, it was all, when I was doing it, it was all analog. Digital was just coming in. I had built maybe one of the first digital systems in New Orleans for the power company. They wanted to experiment with it. And this was back in 1981. So it was the infancy of digital microwave at that point in time, but majority of it was all analog.
Yeah, and you're, at the time you're doing a lot of this, we're going from tubes and going solid state, and talk about the reliability issues there.
Yeah, you talk about tubes. When I was working for Gulf Oil as a contractor, we were pulling out this Lenkert tube type multiplex that they had out in these platforms. The equipment racks were 9 feet tall. I've never seen a rack that big. You had to use an extension ladder almost to get to the top of it. And, you had this one rack and it was only 3 channels, and we were pulling it out and replacing it with this compact synthesized multiplex that Lenkert made. One shelf unit had 12, it was only that high, it had 12 channels in it. So, I mean, it was just incredible, the difference. And the reliability, of course, well, you're out there constantly changing tubes, apparently. I came in, thankfully, after that era was about over.
Yeah.
Because otherwise, I'd have been riding that boat forever.
Well, the TWT business was a tricky business in the gigahertz area.
Yeah.
So it was good when things moved away from that into solid state. And if you have any questions for Nick, please put them in the chat or in the Q&A. Barney, do you have anything there?
Oh, I see one here. Let me see. Let me open it up a little bit and read it. Any tips on ruggedizing equipment? The question, it has to be rugged. How about good tip on ruggedizing?
Oh, well, again, you know, my ruggedization is on the radio tower sites to make sure that they, the radio infrastructure remains operational. We do it several ways. You know, number one, the radio system can't operate without electricity. So what we do, which is, I think, was different from everyone else, now everybody else is doing it as well. We ran all of our tower sites off of DC power. So we have these huge battery plants and we size them for the full load capacity of the site. So if we have a 24-channel trunk radio system, the battery plant is sized to operate that system for an 8-hour period. I think I've sent you some photographs, and in one of them, there's a picture of what one of these battery plants looks like. It's quite large. But, you know, the idea is if you've lost electric power and you rely only on a generator, well, the odds are, at least in my experience, the odds are that there's about a 30% chance that it's not going to start. So what do you do then? You know, you can't have the radio site go off the air. By having a large battery plant, you give the technicians time to physically get out to the location, make repairs to the generator, or roll a second generator up. We always have a socket on these equipment buildings where you could plug an auxiliary generator in. And the users, the radio users, don't know anything has happened. They continue to operate unimpeded. And that's the whole idea. You want to make sure these radio networks do not fail for public safety. When somebody calls 911, they expect the call to go through and they expect somebody to show up. That means the radio piece has to work every time. And that's why this is so important. The other thing is for antennas. If you're building a microwave network in ice-prone areas, you better have ice shields on top of each one of those microwave dish antennas to prevent them from being damaged from falling ice off the tower. Ice will accumulate on the tower with wind, it'll break loose, and you got a big chunk of ice that comes down and hits one of these antennas. It's going to deform it or destroy it, one of the two. So you have to have ice shields on those. Likewise, on the ground, you should have an ice shield over the equipment building so you don't damage it, or the power generator, standby generator, if it's outdoors, it should have an ice shield as well as a fuel system. Oh, and as far as fuel systems for generators, I learned this from Exxon. You know, Exxon makes diesel, lots of it, but on all of our radio sites, we never use diesel. It was always natural gas, LPG gas, or on the production platforms, it was waste gas that came from the well to run the generators. They didn't want to use diesel because diesel, not only is it messy, it has a tendency to foul up and have other issues with the machinery and the filtration system for the fuel. So in order to make sure that we always had electrical power at these sites, we try to configure them for dual feed, whereas you have both natural gas and LPG gas at the site. If one fails, the other one's still there and the generator's running. Yep. But the key is to have battery backup. Lots of people put UPSs at these tower sites, which doesn't make sense to me at all, because you're taking 120 volts AC, converting it to DC to run a stack of batteries, and converting that through inverters back to AC, and it goes to base stations that have AC power supplies in them to convert it back to DC. You know, there's too many conversions. Things can go wrong, generates too much heat in the equipment building, which means that you have to have higher capacity HVA systems in in the shelters as well. So batteries are the way to go. No moving parts.
Nick, let's take a look at some of your photos here. Do you see the screen share?
Yeah.
Okay, so let's go down. I think some of these photos are pretty incredible that you have. You've talked about a lot of this stuff. You talked about Hurricane Katrina, some of the facts and all that. You just talked about the various methods of powering systems, and then here's what happens when everything really goes bad. And talk about what we're seeing here. Look what happens.
Okay. All right. This is Hurricane Katrina. It took 43 days to drain the city of New Orleans, to pump it out after the Corps of Engineers levee system failed, broke down, flooded the city. That's why I say we had between 12 and 20 feet of water in New Orleans, 80% of it. So it all had to be pumped out. Now these brown lines that you see on the doorway here, that gives you an indication of the water level at various stages of the time in which it was pumped out. Now you would think, in looking at this, well, gee, okay, well, it probably got to about maybe 5 feet. In actuality, the water actually went all the way up to the roof of this area here and then came down. Initially came up very high, then settled down, and it stayed there. And that's why those bands are like they are, very dark for a long period of time. So people see this and they really don't. I said, okay, well, that's bad, but wait till you look what happens inside of a house. I mean, the walls are molded. There's mold growing everywhere. You have to strip the entire house out and treat the studs and the wiring inside the house so it doesn't grow mold. It's horrible. And when you figure that, the city of New Orleans probably had, I don't know, a couple of 100,000 homes in it, and 80% of them are like this.
Yeah, it really,
what an environmental catastrophe it was.
Right. So talk about the battery stack here.
There you go. That's the battery plant I was talking about. This is a typical battery plant sized to operate a 24-channel trunk radio system for an 8-hour period. This is what's going to keep you alive when you've lost electrical power and the generators doesn't work. It's shut down. It hadn't started up. And you're still on the air, though, because of this. And it gives your technicians time to repair the problem before the users suddenly have a major coverage and capacity issue, where suddenly a tower site or group of tower sites goes off the air. And then you have no communications. In a disaster like New Orleans, you have then no command and control. The city will go into chaos mode. And in fact, it did.
And you've talked about hardening and designing radio towers. And well, look at this, Nick. What's going on?
Well, this is why you don't build tubular type towers along the Gulf Coast, because you don't know what's going on inside that tube. Now, this is a tower that one of my customers had, and I was concerned about it. I wanted to have a ping test done. Now, a ping test is an ultrasonic test to see how thick the material is in a hollow tube tower and if there's any corrosion. So I sent a poor tower crew up there to inspect, and he said, I've got this little spot here. And then he hit it with this hammer, and you can see what happened. Well, he took the hammer out, and I screamed at him, wait a minute, that's the only good steel in the tower. Put it back in. Needless to say, you don't want a tower like that.
No.
And that was only in service about 25 years.
And ice shields in Louisiana, really?
Oh, no. Well, we do work all over the United States. So up in Kansas City, Missouri, they do get a lot of ice accumulation on towers. So we put shields like this, but an ice shield is actually a good thing to have in a coastal area. I was, again, back in my oil field days, I happened to be down at one tower site down in Venice, Louisiana, which just looks nothing like Venice, I can tell you. And there was a tower crew there working on hoisting up a new mount for a microwave antenna. I was there for another reason. And suddenly this mount got away from them, dropped, hit the a Texaco microwave shelter at the base, and it exploded the sides out of the building. It hit the roof and then the sides blew out. Man, that convinced me that having an ice shield over an equipment building is not a bad thing to have, even in the sunny South.
Yeah, and protecting your feed lines and
Yes.
AC generators.
Yeah, same thing. You'd put these ice shields above the transmission lines and the generators, protect them from falling ice.
Yeah.
Or tower debris in case a tower climber drops something.
How about this auxiliary connector, Nick?
Right, that's what I was talking about before. If your generator at a radio site was to fail, this will allow you to bring a trailer-mounted generator to the site and plug it in. It's an Appleton connector, very large, quite expensive too, but they're designed to handle the 200 ampere service. So you just plug in there. There's a manual switch inside the building that transfers away from city power and the generator that's died to this one, and it'll operate your site.
Yeah, and you're going again.
Yes.
So yeah, those are the great pictures that I and thank you so much for putting that together, because those pictures really tell the story.
Well, that's the thing. It's one thing to talk about hardening, but having photographs to show, how you can do it. And certainly I would guess some of the audience members will look at that and say, well, gee, maybe I can do something similar to that or adapt that idea for my particular purpose.
Yep. And so Barney, do we have any questions in the chat or in the Q&A?
Well, I'll first say there have been a couple of comments about Q&A has links to buy both Marty's book and Wes's The Book About Wes. Those links are up in Q&A if you're interested. You've been talking about hardening the hardware. Does the training issue of the personnel enter into the hardening equation at all?
Oh, yeah, right, it does. You need to train people on the unexpected. That is, not just how to operate the radios normally, but also they're generally in these systems, we'll install capabilities for backup communications using conventional radio networks other than trunking. The users don't use them very often. In fact, a good trunk radio system will never go into fail-off where you would have to utilize a conventional radio network. So even if it was to happen, it happens so infrequently, they don't know how to use it. So it's a case of you need to have training for those eventualities so people are comfortable in using the backup features that are built into their radio equipment. So training is a very important thing. Now, a lot of times, I've been involved with clients that do these either tabletop exercises or they'll have a field exercise where they go through a drill where there's a hurricane or a flood or whatever. But the odd thing is they never cause a failure of some sort in the radio system. Throw the users a curve to figure out whether or not they can adapt on the fly to continue to communicate and maintain communication with their dispatch centers and their supervisors. They don't do that, and that's a very big mistake. A lot of the problems that happened on the field in Hurricane Katrina was a case of users not knowing how to operate radios on alternative systems that were already built in.
Arnie, another question.
Do you include lightning protection in your hardening techniques?
No, absolutely. Every transmission line has gas tube protectors. transmission lines on the towers are bonded to the tower steel at 100-foot intervals. There is an elaborate ground system that's built at the site around the building structure and the tower. And we use only a single point ground in the communications building. So your transmission lines are bonded to the same point as the electrical utility and any external services that come into the structure. It's all one point of reference. So that way, when there is a tower hit, everything floats up in potential and comes down at the same time, and nothing blows up.
Keep going, Barney.
Is that one of the newer things that I'm sure has come into play is cybersecurity. Is that entering into the hardening equation?
Oh, sure. I mean, the vendors, the radio system vendors in particular, utilize hardening techniques and continuously are updating software to protect the radio systems from intrusion from outside. That's a good and a bad part of these complex trunk radio systems now that are utilizing lots of interoperability to adjacent jurisdictions. Sometimes it's done using leased facilities from telephone companies or in fact, in some cases, even the internet. And that's scary because the way to get into these networks isn't head on. It's always some little device that's hanging out on the end is a sneak way in. So yeah, you have to be vigilant in terms of maintaining software on these radio networks. It's key to do it. You can't just build them and walk away. If you do, you're going to wind up having lots of problems.
A question popped up here that I'm not sure I understand. I don't know what it is actually speaking to, the words they use about it. Static cats.
A what?
Static cats, C-A-T-S.
I'm not sure what that is.
Okay, well.
It might be some of those deals you see on the tops that look like porcupines.
Oh.
Static.
Yeah, lightning dissipation system.
Right. Yeah.
Right.
Yeah. Air terminal types.
I actually did one of those in New Orleans at the fire department dispatch center. They had a 350-foot self-supporting tower, and it's right next to the dispatch center. They've since changed this, but at that time, the dispatchers would complain every time there was a lightning storm, which happens, like about every other day in New Orleans in the summer. Every time there would be a lightning strike nearby, they'd feel this tingle in their ears because they're wearing earpieces, headsets, So we put one of it looks like an umbrella that went on the top of the tower above the antennas. And it has all these little spikes, which helps to collect and gradually dissipate the charge down the tower without a strike itself. And that really worked. It did actually work. It's pretty cumbersome and expensive to put up, but
But it worked.
When you got people involved, you don't want electrocuted. So.
Right.
To shift slightly, but based on the pictures you were putting up, Nick, comment is the FCC has an open proceeding, docket 21-346, asking how to make networks more resilient. Have you considered filing your slides in that proceeding?
We did this in the aftermath of Hurricane Katrina. And there were some changes that were made, particularly with the cellular providers at the time, requiring cell sites to have battery backup and generators and other equipment to make them more resilient. But what happened is that gradually these backup systems either are not being maintained or they're falling into disrepair or they're just simply being turned off. I can go to any number of tower sites in Mississippi, for example, because I've done this just recently, and seen locations that had these backup systems and they're no longer operational. It can't operate if the gas line between the meter and the generator is disconnected. So that's a pretty good clue. So it's one thing to have regulation. It's another thing to have verification. And that's the problem with regulations that aren't verified, because it's very easy for the bad habits to creep back in.
Any other questions, Barney?
Yeah, I'm going to switch gears a little bit. And Nick, you talked in writing your book about how you thought the content might help inspire younger people. Can you offer any other thoughts of what we as people in the industry can do to encourage younger people to get involved in this field?
Well, they're not going to come to us. We have to come to them. And what I've done locally with a couple of other fellows is we've actually gone out to schools, the middle schools, to talk about careers in engineering, to try to get young people interested in it. I am hopeful. I've heard evidence from people I've talked to that some high schools are starting to build ham radio clubs again. Now that propagation is coming back, I think it's incumbent upon us hams to try to show kids that, man, this is really neat stuff. You know, how incredible is it that you can have a radio transmitter that doesn't consume as much power as a 60-watt light bulb, and it can communicate with someone without wires on the other side of the world. It's just incredible to me. And I think that's what captured the imagination of probably every one of us hams that's listening in right now. You know, somebody brought us into their ham shack or exposed us in a way to see that you could do this and how neat it is. It's just fascinating. I'm as excited about ham radio today as I was when I was 10 years old. And I'm sure you guys are too.
Well, I want to thank Barney for doing an excellent job with the Q&A tonight. And Nick, if somebody has a question that they didn't get answered tonight, how can they contact you?
They can send an email to nick.tusa@tusaconsulting.com. That'd be probably the easiest way to get me, because I check that several times a day.
No, that's great. Now, I want to thank you so much for coming on. And to those of you who are interested in the Radio Club of America, please go to the website, radioclubofamerica.org. Take a look in the chat for information on how to get Marty Cooper's book, and also for information on how to compete in the donation trail for the 2 CW keys that were used for the transatlantic test this past weekend by our president, John Fasella. Nick, I want to thank you so much for your contributions to the art, both professionally and with amateur radio. And I can't wait to read your book. And we look forward to many more things. And hopefully we'll get to see you at one of these ham conventions or at IWCE or one of these places. I'd really love to hook up with you. And if you're ever in Western Pennsylvania, you can come take a little tour here, and Barney and I will take you out to dinner.
Oh, I'd love to do that. I can't wait to see that antenna farm. That looks great.
Bring some of the big iron here.
Oh, I won't be doing that. The last big iron I brought filled up the back of my Suburban quite well.
Well, Nick, thanks so much. And Barney, thank you. And to everybody who was on tonight, we hope you enjoyed it. This was recorded, and it will be available for playback off of the radioclubofamerica.org website. Until next month, all the best from the Radio Club of America.